Oi, training large language models to reason in a continuous latent space. This paper has a lot of buzz around it, along with some other ones at Meta coming out right now recently that I'm also going to discuss today. We're going to discuss the large concept model paper today as well. And overall, my opinion is a little bit lukewarm, but you might like it a lot getting these models to actually reason in a continuous space as opposed to individual tokens is nice, kind of divorcing us from tokenizers a bit. It's very exciting to be fair. And even though I'm a bit lukewarm on these specifically, I do think that they are precursors to what will come out sometime this year of like very cool versions of these that'll be much more efficient and whatnot. So if you want to learn, stick around, I guess. Disclaimer. Before we start, remember to like, subscribe, comment, share, all the YouTube things. Join the Discord server, follow on Twitter, connect on LinkedIn, support me either through Patreon or YouTube. For as low as $1 per month, you can get early access to my videos, or for a one-time payment, hit my Venmo. And if you'd like to borrow my brain for an hour or two, book a consultation call. All links are over on my Linktree. Let's get started. So, neuroimaging studies have consistently shown that the language network, a set of brain regions responsible for language comprehension and production, remains largely inactive during various reasoning tasks, right? Human language is optimized for communication rather than reasoning. This is a huge thing that I've been saying for a while. Not that I'm the first to say it or anything, but I don't want to get on too huge of a tangent, basically. But most of your actual creativity and reasoning, I mean, by most, I mean all of it, is done subconsciously, is done not in direct languagey thoughts, but just like other parts of your brain. You may or may not have an internal monologue. So by that I mean like some people when they think, they actually kind of hear the words in their head and they have to say the words kind of thing. Whereas some people don't do that. What's actually happening there is it's not that like those people are fundamentally different brains or anything. What's actually happening there is that people who are doing the languagey thoughts in their head, who are under the impression that their thoughts are all language based, are just really in their left brain, really in it. Like their consciousness is centered right there, and they are lacking the kind of self awareness and like total encompassingness of their brain and body to like understand what's happening in the right brain, all the stuff that's actually happening there. I used to think that, or be under the impression, I guess, to using the word many times, I used to be under the impression that I was a person who uses an internal monologue to think, and that all of my thoughts I can hear them in my head, my own voice, right? The reality is that most of the actual thinking is done subconsciously without actual language words, just like in concepts. Uh, Kyle Shine asked if I mean symbolically. Depends on what you mean symbolically. Symbolically usually I believe refers to more like hard symbolic rules and things. I would more so say like association wise, like it's more obviously more neural because like neurons and everything. Um, but over time I kind of learned how to be more aware of the actual thoughts that were more in concepts. The way I would, if you were a person who's under the impression that you think in terms of like explicit language thoughts in your head, like a monologue, the way that I can help you get around this is by saying what's happening in your brain when a word is on the tip of your tongue. That phenomenon where like you know what it is, but like you can't say, like the language isn't quite there. That same feeling of like knowing what it is that kind of symbolic neural non-language thinking. If you're doing it all the time, you're just not very aware of it. You're very not aware of that part of you. Go meditate to figure that out, right? But it works. Some people are very aware of this in the first place. They never actually have an internal monologue. They're very much in the right brain, and the left, like the language is only used when it needs to communicate, right? And the way that language evolved is for communication. It is for with other people. And that's like the purpose of it, right? We had reasoning abilities to some degree, large degree, before language likely. Now we did unlock with language things like actual symbolic, like heavy, strict symbolic reasoning, like proofs and things. That's great, and that's been helpful, like full on like rational chains of logic you learn like a philosophy class type thing. But most of actual reasoning and work at a given job, and especially creativity, is all done subconsciously, you'd call it, with these concepts. But then a significant issue arises when LLMs use language for reasoning. The amount of reasoning required for each particular reasoning token varies greatly. And remember, like when they use language for reasoning, they're like they have to say the actual words to reason, right? Because we do not let them keep using their actual internal representations what the neurons are making, because we match those representations to an actual token and then use that token, and that token has a discrete, like each token is an embedding vector, there is a discrete number of embedding vectors, so they are forced to actually do their thinking, their like logical thinking and everything in language, which again, language is not designed for. And then further, the amount of reasoning required for each particular reasoning token varies greatly. Some next words that you say are very difficult to think of. They're very complex and intricate in the way you get to them. Others are pretty simple. The and are all like whatever, right? Actually, is a pause token. That's funny. Um, but most tokens in a reasoning chain are generated solely for fluency, contributing little to the actual reasoning process, right? So technically, you can, with those tokens, the actual like filler words, I guess you call them, like the not important most words, the important words of the sentence. They do get used in computation because signals do flow across the attention mechanism and everything. They can be used. Um, like they make the network wider, you might say, but they are not actually fundamentally for that purpose, and they're not optimized for that purpose, right? So anything that does get used that way is just like downstream of like the result of its useful. It's not actually made for that. Now, it would be more ideal if LLMs had the freedom to reason without any language constraints and then translate their findings into language only when necessary. Todd pointed out that if we can get models to stop like using explicit language and start using just internal kind of thought like vector embeddings and structures and things, that we lose the insight of what the model is thinking as opposed to what they're saying. Um, and yeah, and from like a pure alignment perspective, obviously that's less than ideal. Personally though, I'm not very into the whole like be afraid of the robots type thing. In my opinion, like it'd be really weird, Todd, if I were to force a constraint on you that you're not allowed to think without me hearing it first. I don't like this whole thing. I think a lot of traditional simple alignment is very control based, very like ego based, very like slave master slave based. And even though if it's not meant that way in the beginning, if you're just trying to be like you're scared of the possibility of the model going crazy because you watch too many sci-fi movies and whatever, it will devolve into that eventually if we let that thought process keep going, rather than just giving benefit of the doubts and just training models with good benevolent data in the first place. Just take out the bad data. Come on. There's other things to do. Obviously, I'm oversimplifying stuff. Todd, we are not machines, though. Yeah, we are. In this work, we instead explore LLM reasoning in a latent space by introducing a novel paradigm, coconut, chain of continuous thought. It involves simple modification to the traditional chain of thought process. Instead of mapping between hidden states and language tokens using the language model head and embedding layer, coconut directly feeds the last hidden state of continuous thought as the input embedding for the next token. This is cool. It's been attempted a couple times before, but just none very well. Kyle Shine in the chat fired back that we are biological machines. I don't care about the substrate personally. Computation is computation in my book, unless you can prove some really hard quantum stuff, which even then, still computation. I really don't see any merits to any. We are different. Like we are some fundamentally superior difference from silicon-based intelligence. I think there's differences in the sense of like the substrate you're in does result in differences. Like digital things can be copied, whereas analog, aka carbon-based, biological-based cannot be copied. There's like implementation differences, but fundamentally there's no like limitation of what can be done on the system. We're all just the math, the pattern, the machine in my book. Back to the paper though. So this method, what they're doing, I just kind of said it, but like it's a lot of like formally sounding words. You run the model, right? And then rather than matching up the model's final representation internally, its final vector embedding state to the nearest unembedding matrix state for a given token, rather than matching those up and then selecting a token and then using that token embedding vector as the next input, you just use that model's last embedding state raw as it is, never match it to a token, just copy it and input it back into the model, right? Now this has been avoided for a while, like it's been tried a few times, and like it's tough to do because like now suddenly you break the parallelizability of actually training these models. It's very important usually to be able to say like, oh, if we have a given model, a GPT, right? What we do is called teacher forcing, where basically usually in training models we can do all this stuff in parallel. For every given input, every individual word and every all the precursor words, we put them into the model, and then there is obviously an output ideal. So when you put in the word I, you want it to say think. When you put in the words I and think, you want it to say therefore, and etc. until you get I think therefore I am. And this is done in parallel massively in the actual training process, right? Which is important because this parallelizability allows us to actually send massive amounts of data all at once in equal gradient proportion through the model. Whereas what models used to do with the current neural networks, right, was take an input word and they use their own hidden states and go out and you like feed the words in one at a time, right? So this has gradient issues, all this stuff. But the methodology they're introducing here effectively reintroduces the issue of RNNs, of the serialness, back into the problem, like back into the model, right? Meaning this is not a pre-training technique. This is not a massive parallel pre-training technique. What you are forced to do now is this is like some very inefficient fine-tuning type stuff that we can do after the fact in the hopes that it's worth the break in parallelization, that it actually has huge benefits on reasoning is the goal, right? What it actually looks like in terms of these diagrams, right, is instead of matching to a token right here, we grab that final hidden state, right? Let's call it H actually. And then we pump it back into the model and do so again and again. And then this circle, this process is the serialization we're sitting here. And this is what slows things down effectively. Back to the chat. Todd, it's not a great time for full sentience arguments. We'll get back to that when it's just live stream, not video recording. Bad rates Abacus thought about, he said he thought about me when, or they said they thought about me when the concept model paper came out. Have I checked it out? I have. Not going to do a video on it. So for those of you who don't know, this paper is by Meta, training models to reason using latent space. It is similar. It is in a family of a couple papers come out recently by Meta that are all pretty getting hyped up. And that one in particular was sent to me because it's very similar stuff I've been talking about. I've been like predicting basically for months now. And the way they did it, in my opinion, in that paper, I'm just not super fond of. It's this one we're referring to, large concept models. Basically, the goal is good for this one, but my opinion is the implementation is still ugly, and that we're not going to get this to really pop off in reality until we can get the implementation to be very pretty and efficient. And there is a trick that will be found, I think, in the next year. Someone's going to figure out how to do this well. I'm hoping it's me, but we'll see. Back to the main paper. Let's get into more about how this actual method is done. So, of course, you have to separate between the tokens. Tell you what, bad rate because if I have time, remember at the end of this paper, I'll add on more talk about the actual other paper. Might as well just combine them into one, I guess, now that we're already totally off track on the live stream, but whatever. Anyways, back to it. So, special tokens, we actually have to add them to this whole method of work here today, is the beginning of token, or beginning of thinking, I guess, and end of thinking. And they just act as separators between those two states. So in reality, on this diagram, what we have instead is something like this, where each tokens are split up, and then we indicate to the model, hey, this token means we're no longer going to be doing token stuff. You can start just thinking in the abstract now, when you'll have multiple runs to do so. And then we plug in its own hidden states until finally it's done. And we'll get to later how we decide how long to actually let this happen. And then we allow it to keep generating and give us the rest of the actual tokens in the sequence, right? Implementation detail, not too big, is we do actually normalize these representations that we pass through, of course, back into the model. And even though we're not actually checking for the token output of that given thought process, that given representation, you can still output, multiply by the actual output layer and get out a distribution over the tokens to see like roughly what is it thinking, what might it be thinking, which isn't a perfect method to actually judge that kind of thing, but a logit lens is very like a commonly used method for sure, and still pretty reasonable, especially that it's very simple. And then in terms of the actual training procedure, right? We start off with just like, this is part of the issue with this method, I think, is we have to take initial chain of thought instances where the model is prompted to actually give out a chain of thoughts before it gives the answer, and we just start our training on those, right? Already, this is not a pre-training thing. This is like a post-training technique, right? I really think that in terms of getting models to think for themselves and everything dynamically, you have to figure out a way to implement it into pre-training. Otherwise, it's just not going to give huge benefits, in my personal prediction opinion. Then that's the initial stage, right? Just train it on chain of thought, right? So just chain of thought tokens. Then in subsequent stages, what we do is we just take some number of those chain of thought tokens and just replace them with the continuous thoughts, right? And we do this up the number over time. So at the case stage, we replace the first k reasoning steps in the chain of thought with those intermediate representation vectors. There's a lot of more like implementation details that are more in the weeds if you want to replicate this thing, like the fact that you actually don't um, put loss onto these hidden state vectors. You actually just put them still in the tokens, right? And so you have this gap in the actual parallelization of the model, or the actual like the run throughs where like those hidden states receive no loss directly. They just receive loss indirectly through the actual sequential RNN type setup, right? Kyle Shane asked, what does K mean again in K stage? It's saying like our first stage, we do chain of thought training. We just like give the model chain of thought data and just say, do more of this, please. Train on this. Then our second stage, so like I guess k equals one at second stage, I suppose. We replace one token in the chain of thought. Instead of giving it the token, we give it just the actual internal model representation. And then we do more and more training stages where we up that k number. So now we're replacing two of the chain of thought tokens with the internal recurrent hidden states, right? And then now for k equals 3, we're doing 3 of them. We just like, there's multiple stages of this training in which we increase the number, because you don't want to just like suddenly tell the model, oh, we're going to just run you 12 times and put all 12 vectors in there and hope that you figure it out kind of thing. That's just the odds that like that diverges or something, or that goes way off course, is just way too high. Or at least that's what they assumed in the design. You could have tried it and see if it worked. So part of the thing with the fact that they are not actually putting any loss directly on the hidden representations means that the objective actually does not encourage the continuous thought to compress the removed language thought, but rather just facilitates the prediction of future reasoning, right? So we have no way to encourage the model to actually use fewer of these continuous thoughts yet. That's not done here. So hopefully at some point we could learn a better method than that, right? And because we are just asking it to facilitate the prediction of future reasoning, just predict the future final answer better, it could be the case that the model actually just through training gradient descent does find a better result, a better actual method than whatever the initial human chain of thought data we were training on initially was. It could be the model just finds something better and gets a better result, period, potentially. Kyo Shine said, do I think before I speak, or do I just append the most meaningful words sequentially when conversing? Um, Sometimes you can think before you speak. That's usually a more purposefully done thing. I do think that just the most meaningful next word is not quite right. Especially if a word is roughly 1.3 tokens. A lot of brain studies find that brains actually predict roughly 4 tokens ahead. This is some old tokenizers, so like maybe 3.5 tokens ahead or something now, but still, is that's not quite the level of resolution we're working at, and that's just for predicting the specifics from the actual language part of your brain. Again, as earlier we talked about the whole like right side of your brain doing like abstract reasoning or whatever it is, the associative reasoning, and most of the actual reasoning. The reality, I think, of the brain is that we are predicting at multiple scales at once, right? So we're predicting at the level of like tokenish word level, as well as like sentence-ish level, as well as like paragraph, and then like whole, even like up to like, honestly, I think it probably gets pretty big. I think it probably like part of your brain is predicting like very far ahead, just in a very like loose way. So these models, again, just base GPTs only do that little token level. We probably have a lot to gain from finding a way to do like hierarchical prediction of higher layers, like higher levels of abstraction all at once. And then Tej suggested to achieve stopping of thinking, you need to establish some coherence metric where all neurons and state representations of knowledge I memorize and learn info are optimally linked. I'm not fond of the idea of a coherence metric. I could be misunderstanding you possibly, um, but preferably I'd like a way that is actually like unsupervised trainable. It's what you always want. That's the gold standard, right? If you can find like an unsupervised training method, um, just using a metric per se is not the most ideal. I'm not sure what metric you'd actually use there, how it would work. Okay, back to the paper. So a challenge lies in determining when to switch between latent and language models. So we insert that beginning of thinking token, right, immediately following the question token. So we have a data set, right, in this chain of thought data set. It is really just like an instruct data set. So it's a question and a chain of thought, then an answer, and I believe it's human made data, I believe, right? And so pretty simple here. They're beginning of thinking. They just put that right after the question. And then for the end of thinking, as to like when to tell the model to predict an end of thought, like to get out of this whole like recurrent regime and get back to predicting tokens, they look at two different strategies. The first is to train a binary classifier on latent thoughts to enable the model to autonomously decide when to terminate the latent reasoning. And the second is to always pad the latent thoughts to a constant length. They found that both approaches work comparably well, and so they use the second option in their experiments. So this I thought was so silly. Maybe misunderstanding something somewhere, but like the training data was on a fixed set of actual latents, right? Like the stage they did increase those latents over the course of training all the stages and everything. They increased the number k, right? But the training data itself was a fixed number of latents. Why even bother with the binary classifier if you're going to have train in a fixed number of latents? Obviously, it's not going to predict a whole lot of variation at that point in the actual number of latents if it's trained on that fixed number. So that I thought just made no serious point. If I'm misunderstanding something, let me know. So that was the method. I honestly feel like I overcomplicated it along with all the like live stream talking. It's relatively simple. You just take the output states before your actual embedding layer, and you feed it back in to the model just a couple times, and then hopefully it improves, kind of thing. Um, they experiment was on a GPT-2, which I thought was odd for a meta paper, but whatever, no biggie. And relatively small too, a batch size of 128. So again, for a meta paper, I assume they have more funding than that. But weird, good to see a relatively small thing. It sounds like this could be done by an amateur with like $1,000. Is what it sounds like. More than that because they have mini models, obviously, and it's like a recurrent, inefficient training process. But like you can do experiments relatively small scale and still get published and still be thought of highly. So they have two different reasoning benchmark measurements. One is math, one is logical reasoning. The math only uses two latent thoughts, or is it 3 by 2, so 6? That's a little confusing, but not that many. And at the end of these, the model is just doing the tokens of questions, the continuous representations, the actual method, and then the answer. There is no actually any more language based chain of thought, right? Their baselines being traditional chain of thought, no chain of thought at all, which is obviously the worst, I would assume. A method called I chain of thought, which is just a more complicated way to train on chain of thought, basically. And it still works at the token level. They do some pruning of actual tokens. It's a whole thing. The one I'm familiar with is pause tokens. And pause tokens are weird. It's the same token every time that they add instead of chain of thoughts, and they just add multiple of them, right? And the idea being that the model no longer actually gets extra run throughs of layers, so not more sequential processing, but it does get more parallel processing. The actual width, if you define like sequence like that's width, gets wider. So the idea being hopefully that helps to some degree. And the way they call it a pause token, as well as some ablations variants of their own method. And results overall, pretty meh. Pretty meh. My opinion is that these three big hyped up meta papers recently are definitely like engineering wise. Like yes, you tried the thing we were all thinking, I guess, but I don't think they any of them implementation wise were actually good enough to warrant like the amount of hype they're getting, in my opinion. Interesting thing though, they did some actual experiments at the end to try and figure out what was actually happening with this latent reasoning in their model. And what they found is that unlike chain of thought, which is like sequential, linear, whatever you would call it, it's like a single stream of reasoning, right? In this coconut method, because it's continuous latent space that it's working in, the model could actually hold multiple ideas at once, aka do a kind of tree search. I'm not going to get into the whole specifics of the questions they were testing on and everything. They were effectively using like a logit lens though to figure out which potential next tokens are being thought about and being considered basically, and they found that the model would think of multiple tokens at once and they would trim down that list over the course of every single one of these recurrent continuous reasoning steps. And it's not simple depth first or breadth first search, whereas chain of thought is depth first, obviously. If you were to run many chain of thoughts in parallel, that would be breadth first. This method is effectively an intelligent search algorithm that's far more efficient than either, at least when analyzing it, it seemed that way. Of course, the results weren't amazing or anything in the main benchmarks. That's the end of that paper. Because the one viewer was asking for it, because I don't plan on doing an actual video on the other paper, I want to just clarify what I was talking about with the large concept models and why I overall wasn't absurdly fond of the whole thing. Like, yes, I want to do this, something like this in a similar way, and it's definitely some good groundwork. It's fantastic groundwork and everything. But at the end of the day, this current implementation is not the one that's going to just revolutionize everything and be the one that gets used in the future. First up, they used a pre-trains embedding, or sorry, encoder decoder for the actual input output parts to get into their kind of conceptual space. Don't get me wrong, in terms of implementation ease and everything, like that makes sense for a first go and whatnot, but really we do need an end-to-end train version. And more importantly, is that we need a version that the actual distinctions in these sentences and these gaps between the concepts, right, and like how we draw between them, we need to be learnable as well. Like this whole like let's just use the grammar, the syntax of the sentence, and split things up that way, and have a maximum size given our like what our GPU can handle and everything is just really not ideal. The odds that sentences are actually the correct level, I think, is pretty low. Sentence structure, if anything, has more to do with grammar than it does with the actual concepts per se. And it's like I didn't go in depth on like how they're actually storing this in the tensors or anything, but like at least in terms of one way I can think of to do it, it's like how do you actually efficiently pack all of this stuff into your tensors is another issue here. Is like the more empty padding tokens you have to use, the worse this end up being efficiency wise. And so I'm just not fond of the actual method of splitting up the data into sentences, into concepts, and then of the fixed encoding of them. Another thing that I thought was just silly, in order to get the concepts model, the sentence level model to stop thinking, they used an end of text like sentence as their actual indicator, which I mean makes sense, I guess, but it's also like, oh, so what if you train on this document here and it's now told to predict end of text as a sentence as part of this document on training? Like this doesn't make like you don't want to actually use something like that. We need a better way to indicate end of the actual sequence. I might even say like it might make sense to just use the actual end of sequence token at that lower level, at the sentence level. That make a lot of sense, honestly. Um, Although it would mean that you might end up with if you're decoding any attempting to decode very efficiently, you might go too many steps ahead on your actual sentence level autoregressive generation. But just the idea of an end of text sentence and using that as your end of sequence is just kind of weird to me. Even more preferably, I'd love like just a more clever solution. Period. And then using diffusion, this was good. I wasn't sure if they would get to this, but great to see. Of course, you have to because it's a continuous actual latent space. But then in terms of implementation, again, not super fond of this actual technique. The using two different transformers and the one on the right, one with just regular, effectively decoding, other one being like a diffusion one. It's kind of clunky, as well as the one on the left, the initial one tower LCM is just very like in terms of quadratic complexity of the actual sequence. Like you're doubling your sequence length, you're doubling your sequence length. That's obviously bad. Hence why the one on the right was made. But it's just these things. This paper basically, to like sum it up, said to me like, oh, they have the same intuition I have as to what could be good if done well, but in order to make it happen, they were rather than like finding the final solution we'll eventually have someone eventually think of that's like very clean and pretty, they were really just like using engineering trick after engineering trick after engineering trick to like try and like cram this thing into being what they wanted it to be, which like worked pretty well. And like I great efforts and great paper to cite in the future. I just don't think that this is going to be the specific way things are done in the future. It has too many problems. We need a prettier way, and there by that I mean more efficient way to do this. Reminds you of Michael Levin. What do you mean by this? The paper? The paper reminds you of Michael Levin? Is this what Nvidia was talking about last night? I have no clue, but they might have mentioned it. Tej says they haven't read the LCM paper, but didn't Anthropic already show us LMs naturally create concept maps anyway? I think you're referring to their sparse autoencoders. This is very much a different thing. Yeah, no, this is a very much a different thing when talking about concepts. The concepts here are like we're actually just like embedding sentences and doing autoregressive prediction on sentences. What they mean. Then there were like again like not only were the everything just like very crammed in terms of like trying to make stuff work. There was some stuff that I thought was just straight up questionable. Maybe I don't understand it on those little pieces, but to me like there were entire parts where I was like you just shouldn't even include that. I think like why are we padding this right here? Why is there like this module even here at all kind of thing? Um, could be an understanding issue, but I really think it was just like they were trying everything they could to make this thing work, and some of the stuff was just like thrown in there and hobbled together. So not super fun. Not that I could do better. I've had this idea for such a long time and I have not done better. Obviously, I don't mean to like put um I don't mean to disrespect their name or anything, but yeah, just overall not crazy fond of this. I think a future version of this same idea is going to be very cool, but this one right now, not great. And anyways, I think that's about it for this one. End of video. Don't forget to like, subscribe, comment, hit the bell, all the YouTube things. Join the Discord server, follow on Twitter, connect on LinkedIn, and consider supporting me monthly either through Patreon or by hitting that YouTube join button down below. For as low as $1 per month, you can get early access to my videos. Or if you're a one-time payment kind of person, hit up my Venmo. And if you want to borrow my brain for a bit, consider booking a paid consultation video call. All of those links are over in my link tree. And yeah, end of video.